So far, we've concentrated on the use of value in drawings done from observation. We want to build on this so that you'll be able to draw from your imagination too. There's a piece that will help you gain greater confidence in drawing from your imagination with value, and that's learning something about projecting cast shadows. As we've done with many problems, we'll start with simple geometric forms and build on this. The goal is to wed your knowledge of geometric solids and perspective to ideas about value to create believable objects in light and shade drawn from your imagination. Since this is really part of linear perspective, it's often termed the perspective of shadows. It involves step-by-step schematic procedures, but like the rest of linear perspective, once you understand the underlying principles, you can apply it very freely, basically eyeballing how you want to construct light and shade in your drawing. As we've already seen, there are a number of variables that affect the way we see the form of an object and the cast shadow it produces. The strength of the light source is a primary one. All else being equal, the sun will dwarf a 300-watt bulb, and a 300-watt bulb will dwarf a match. The type of light is another. Sunlight's different from moonlight, which is different from an incandescent ceiling fixture, which is different from a fluorescent one, which is different again from a flashlight or a campfire. And the shadows created by a strong focused light, say bright sun on a cloudless day, is different from diffuse light, say the shadows we'd see on a gray and overcast day. The position of the light source relative to the object is another important variable, both its distance and angle. So, let's imagine we're looking directly at an object. Light could come from any direction in relation to that object. It could come from directly in front. In this case, the object would produce a partially or fully obscured shadow, because the shadow will be overlapped by the object itself. Light could come from directly behind the object. This leaves the object in shadow, in silhouette, and the cast shadow will project out towards us. Light could also come from the right or left side, and from any of the oblique angles in between these first four positions. With a concentrated light source coming from either the right or left sides, or from right or left oblique angles, we'll get the effects of chiaroscuro as well as defined cast shadows. This is why many naturalistic works are lit in this way. It brings out the form of the object. And the cast shadows help define the spatial orientation of the ground or other large planes. Next, the shape and spatial orientation of the object producing the shadow has a measurable effect on the cast shadow. Similarly, the planar orientation of the surface receiving the shadow will, likewise, influence the cast shadow shape. So, with all these factors, it can get complex. But as we've done before, we'll start with a simple situation and build from there. First, we'll look at a stripped-down, side-lit situation. We'll build from this base and learn how to project cast shadows of blocks and curvilinear solids in 1- and 2-point perspective. Then we'll learn about compound surfaces receiving shadows and inclined planes throwing them. In the next lecture, we'll look into light coming from oblique angles, both from in front and from behind the object. We'll also take a look at artificial light, like a light bulb hanging from the ceiling. In linear perspective, we consider all light rays coming from the sun as being parallel. For drawing purposes, the sun's so far away that any slight differences aren't germane. That's different from the way we conceive of a naked bulb in a room. There, as we'll see, we conceive of the light rays as radiating out from a central point. But for our purposes here, it all stays simple. And this is our first principle. All light rays from the sun are treated as parallel. Let's imagine a pole in the ground. The sun rises in the east. At first, with the sun at a low elevation, the cast shadow is quite long. But as the sun continues to rise, the shadow progressively shortens, until we get to midday when the shadow disappears. Past noon, the shadow begins to extend in the opposite direction. At first, the angle of the light ray is almost vertical and the shadow's short. But as we progress through the afternoon, the shadow lengthens. As the sun sets, we once again get very long shadows. Of course, this is what we experience. Long dramatic shadows at dawn and dusk, minimal shadows at midday. We get shadows pointing west in the morning, east in the afternoon. If the viewer is looking north, shadows go left before noon and right after. So, You can draw whatever length of cast shadow you want, whatever suits your expressive purpose. A key point is that when you're drawing from your imagination, you can inflect time of day and mood through shadow length and direction. Draw along with me here. Even though this involves linear perspective, you could follow along approximating the angles. A pencil and a sketchbook's fine, but if you're more comfortable with a straight edge in your 18 by 24 inch paper, that's fine too. So, we're out in the desert. We have a horizon, and we have a post stuck in the ground. It's a sunny afternoon. One of the sun's parallel light rays glances the top of the pole and extends down toward the ground plane. To draw the shadow of the pole, we extend a horizontal out from the pole's base to meet the ray. And that's our second principle. With side light, to draw the shadow of a vertical that's perpendicular to the ground plane, we extend a horizontal from the base of the vertical to meet the ray of light. We'll use this idea over and over again. It's the basic concept behind projecting all kinds of more complex cast shadows. Now, let's imagine we have a second pole. It's the same height as the first pole, but it's located back behind the first one. First, we place the point where the second pole meets the ground plane. Then, we extend a diagonal from the base of the first pole to the base point of the second, and we continue to the horizon, and that's our vanishing point. From this vanishing point, we draw a diagonal to intersect the top of the first pole. Then, extend a vertical line from the base of the second pole to meet the diagonal. Now we have two poles of equal height, and we can get rid of some of the construction lines. To construct the shadow of the second pole, we'll repeat what we did earlier. All light rays coming from the sun are parallel, so we'll draw a ray of light that's parallel to the first ray. Then a horizontal from the base of the pole to intersect the ray. We've got our shadow. But let's imagine we're really building a wall here. Line up the two poles, top and bottom, draw the lines connecting them, that's the wall. These diagonals will also line up with the vanishing point. Now we need the wall's shadow. As you've likely guessed, all we have to do is to connect the ends of the two post shadows. You may have noticed that this diagonal also lines up with the vanishing point, and that's our third principle. With side light, the shadow of a horizontal edge recedes to the same vanishing point as the edge itself. At this point, you could shade it in if you like. Now, let's imagine we're not just building a wall, but we're building a block in one-point perspective. Draw the front face of our block, and we already have its shadow. For a block that's straddling the horizon in one-point perspective in 90-degree light, the shadow of the block will be the same as the shadow of the block's side plane. Let's do another, but this time we'll start by drawing a block, a transparent one, and we'll put it below the horizon. And we'll make it closer to us in space. Start with the front face on the right side of the page. Take a line from each corner of the rectangle back toward the vanishing point. We'll use the same one we used for the other block. Draw the back face and we've got our block. I've asked you to draw this transparently because we'll need the internal structure to generate the block's cast shadow. The block's vertical edges will function like the vertical posts we drew in the last drawing. Parallel light rays will glance their tops and continue to the ground plane. To mix things up a bit, we'll change the ray's angle, more towards the vertical, make it a little earlier in the afternoon. As we did before, we'll extend horizontals from the vertical's bases to create the cast shadows of these edges. Next, we'll connect these with a diagonal to create the shadow of the top right receding edge of the block. Then, erase the rays and the three lines representing the block's interior. Since this is a solid block, we'll only see the triangular portion of the shadow emerging to the right of the block's right edge, so we'll erase the part of the shadow we wouldn't see. Here's what it would look like shaded in, but don't do this yet in your drawing. The point here is that depending on the point of view, we may need to draw through the object, see it as if we had X-ray vision, and construct the whole cast shadow, then erase the parts we wouldn't see. You may have guessed there's a less complicated way to get this. We could have drawn one ray of light glancing off the far right vertical edge, drawn the shadow of that edge, a horizontal out to meet the ray, and then drawn a line from that intersection back toward the vanishing point. That represents the shadow of the receding top edge of the block. That's our third principle at work. The shadow of an edge vanishes to the same vanishing point as the edge itself. But let's take this in another direction. Get into some additional complexity. Take what you have and erase three things: the triangular cast shadow, the front bottom horizontal, and the left bottom receding diagonal. We'll imagine this as a surface suspended on four posts, like a table or a carport. So we'll add the rear right leg. You can also shade in the top plane if you like. Now for the cast shadow. For each post, we draw a ray of light, all parallel, from the bases, horizontals to intersect. This gives us the post's cast shadows. Now we need the tabletop shadow. We connect the ends of the shadows of the two posts on the right, then the same thing on the left. These diagonals represent the shadows of the two receding edges of the tabletop. They line up with the vanishing point. No surprise, third principle. The shadow of an edge vanishes to the same vanishing point as the edge itself. We have the shadows of the table legs and the receding top edges. We're missing parts of the shadows of the horizontal edges of the tabletop. These partially overlap the cast shadow of the legs on the right. We just need to fill in the gaps. We'll draw a line starting at the cast shadow of the left edge of the tabletop toward the right leg, both in the front and the rear. Shade it in to up the illusion. Now, take out a new sheet of paper and we'll do this in two-point perspective. Draw a horizon, then locate right and left vanishing points at the page's edges. Start with a single post or table leg. Lightly carry both top and bottom back toward the vanishing points. Next, add a right and left leg. From the left leg, we'll recede to the right. From the right to the left. At their intersection, draw the rear leg. Connect these to construct the top plane of the table. Now for the shadow. We'll start with four parallel rays of light, imagining late afternoon. Rays with acute angles to the ground plane producing relatively long shadows. Then intersecting horizontals from each of the legs. We'll connect the front leg's shadow to the shadow directly behind it. This line represents the shadow of the tabletop's right front edge. Then, draw a line from this point to the rear table leg's shadow. This is the shadow of the table's back edge. You've got the idea now. From here, connect to the shadow of the table's far left leg, and back to where we began. If we assign value to the cast shadow's shape, it helps complete the illusion. I've used a mid-gray. This allows for a slightly darker gray for the right table leg, creating a compound shadow. We could equally allow the table's leg's shadow to be subsumed in the shadow of the tabletop. Whether we'd see this or not would depend primarily on the strength of the light source. Once again, the shadows of the tabletop's edges recede to the same vanishing points as the edges themselves. Principle number 3. The long edges of the table and their shadows vanish to the right, the short edges and their shadows to the left. Good to remember this. It's a good check if you get confused. If this table were a solid block, we need to project the cast shadows of the three rightmost vertical edges. Start with a transparent block. Project light rays glancing the tops of the three right vertical edges. Draw intersecting horizontals from the bases. Connect the ends of the horizontal shadows. Now to edit. Get rid of the light ways. Then the internal structure of the block, and the parts of the shadow we wouldn't see. Add some value, and you're done. I'd suggest repeating everything we've done a number of times for practice. It will really help you make this your own. Use both 1- and 2-point perspective. Change the variables in your drawing. Try a low horizon, then a high horizon. The lower the horizon, the more oblique the shadow. The higher, the fatter. Try locating the light source on the right. Try different angles of light. These translate to different shadow lengths. Try different types of blocks, some tall, some squat. Then up the complexity. If the table we drew were an actual table, the legs would have planes as well. Each table leg is really an elongated block. You'd figure the shadow of each leg the same way we did for the block itself. Blocks within blocks. Then try a stack of boxes. Try it freehand, approximating the angles. For most purposes, you'll want to be able to adapt the core principles to freehand drawing. As you do this more and more, it'll become very natural, part of the way you see and think visually. You'll be able to draw more quickly, and it'll help you see how you could apply this to your sketching from your imagination. Let's try some curvilinear solids. We'll start with a transparent cone sitting on a table in front of a wall. This time, light from the right. Draw a ray glancing the cone's point. We can sketch a trapezoid around the cone's elliptical base. Cross diagonals to find the perspectival center. Then a horizontal line out to intersect the light ray. Erase any extra line. Draw diagonals to this point from the close and far edges of the base. Erase the construction lines and those in the cone's interior. Edit as needed. Reduce the line's strength. Then add value to the tabletop and wall and to the cone and cast shadow. Next, a cylinder. Now for a sphere. We'll add parallel light rays glancing the widest point on each side. Then a horizontal line connecting these where the sphere touches the ground plane. We'll draw an ellipse on the center line, and you've got your shadow. Again, edit, erase back the line, and treat everything with value. You might ask, how did you determine how wide to make the ellipse? The short answer is, I made it up. So here's the long answer. We don't know how fat the ellipse of the shadow should be because we haven't established eye level. When we look at a block, a cone, or a cylinder, what we see of each of these forms is dependent on eye level. If we see a block or a cylinder from high above, we'll see a lot of its top plane. As our eye level is lowered, we see less and less. If we imagine these solids as transparent, the same would hold true for their bases. Wider shapes from high above, diminishing to a line at eye level. When we drew the blocks, the cone, and the cylinder, one plane of each of these objects was sitting on the ground plane. The width of that shape indicated eye level, and we projected the cast shadow from the width of that shape, drawing lines out from points where the form met the ground plane, front, back, left, and right. Using this system, a block seen from high above will produce a wider shadow. One closer to eye level, a thinner one. It's built into the system. The spatial orientation of the object was captured by its base and translated to the cast shadow. Spheres are special. They have no plane that coincides with the ground plane. They look identical from any point of view. So when we draw a sphere from our imagination, it, in and of itself, tells us nothing about its spatial orientation, so we have to make this up. Here's a sphere with a cast shadow seen from 3 different heights. Higher, the shadow wider, lower, thinner, lower yet, thinner yet. But the shape of the sphere is identical in each case. So, when we draw the shadow of a sphere, we need to set eye level. If there are other objects in the drawing, block-like things for instance, use their shadows as a guide. If not, and you want greater specificity, draw the cube the sphere would inhabit and use its bottom plane as an indication. Another point here. This isn't just or even primarily a technical problem. When artists draw from their imagination, they think about the expressive difference between long, thin shadows that dissipate slowly and short, hard shadows that end at an abrupt edge. Generally, we want the technical to follow the underlying expressive intent. Up next, cast shadows on compound surfaces, and this is a good bit of fun. You'll need a new sheet of paper. Start with a post in the desert, with a wall to the right, then a ray of light glancing the post's top. Draw a horizontal toward the ray of light, but where it hits the wall, climb up vertically until it hits the light ray. Erase the ray. As the sun sets, the shadow lengthens and climbs farther up the wall. Lower light, longer, or in this case, taller shadow. Let's apply this to a tallish one-point block. Draw one freehand, then add a wall to the right. Draw angled rays of light glancing the block's top right corners. From the right vertical edges of the block, draw horizontals out toward the light rays, but stop at the wall. Then head up vertically to intersect the rays, and connect the top points. This last diagonal line lines up with the vanishing point. That's principle 3 once again. With side light, the shadow of a horizontal edge recedes to the same vanishing point as the edge itself. Add some value, and you've got the cast shadow. Let's try this in 2-point, a little more complicated, but really much the same idea. Start with a transparent 2-point block. Next, a wall behind it. Add light rays glancing the tops of the 3 rightmost vertical edges, and horizontals moving out from their bases. The first will extend fully to the ray of light. The other 2 will end at the wall. From the ends of each of the latter, draw a vertical to intersect the ray. Now for the shadow's outline. Start with the line representing the block's long top edge's shadow. Do this by drawing a line from the end of the shadow of the first vertical edge to intersect with the ray glancing the far right vertical. Stop at the wall. From here, draw a line to the point of intersection of the far right edge with its light ray. This is the same point we'd intersect if the shadow were flat on the ground. Then connect this point to the final vertical edge's shadow and ray intersection. Now, erase the internal structure of the block, the light rays, other construction lines, and the part of the shadow outline we wouldn't see. Erase back the outline, add some value, and you've drawn the cast shadow. Let's do this now with our curvilinear volumes. Draw a tallish transparent cone like this one. Then the trapezoid suggested by the cone's base. Cross diagonals to find its center, and draw a horizontal from the center out to the left. This will help us place the wall we'll draw next. Vanish the trapezoid back to find the vanishing point and horizon. From the vanishing point, we'll draw a wall to the left of the cone. Then a light ray. From the point where the horizontal we drew earlier meets the wall, we'll draw a vertical to intersect the ray on the wall surface. From both the front and back of the elliptical base of the cone, we'll draw lines toward the intersection of the ray with the cone's center line on the ground plane, and we'll stop at their intersection with the wall. From these 2 points, we'll draw diagonals to meet the intersection point on the wall. You can erase the construction lines, edit as needed, and add value at your leisure. Next up, draw a transparent cylinder. Then draw the trapezoid of the cylinder's base. Cross diagonals to find its center, and draw a horizontal from the center out to the right. Project lines to find the vanishing point and horizon. Using the vanishing point, draw a wall to the cylinder's right. Next, a central light ray from the cylinder's lip. Now, a vertical up to intersect the light. 2 more light rays from the widest parts of the top ellipse. Then the horizontal from the wide points of the base out to meet them, but stop at the wall. Draw verticals up to intersect the light rays, and a curve to connect the 3 points of intersection. Erase and edit, and add some value to all the planes. Next, draw a sphere like this one. We'll imagine light from the right and draw 2 light rays in a long cast shadow. Then a trapezoid for the shadow's shape. Project the vanishing point on the horizon. Let's locate a separate vanishing point on the horizon for a wall and draw the wall. From the center of the base of the sphere, we'll draw a horizontal toward the light ray. Stop at the wall. Then draw a vertical to intersect the light ray on the wall. Where the contours of the cast shadow hit the wall, we'll draw a curve arching up to the point of light ray intersection on the wall. Again, erase and edit, and you can treat the drawing with value. Our last topic concerns the cast shadow of inclined planes. Start by drawing an inclined plane like the one I have here. Again, drawing freehand is fine. Next, draw 2 light rays glancing the top corners. Now, we'll need to draw horizontals out from the base of the vertical heights of the corners. So we have to extend a vertical line down from the top corners of the inclined plane to the ground plane. But we don't know where the ground plane should be. In other words, we need to know where the inclined plane would lie if we're lowered down to the ground. There are a number of ways to do this. If we want real accuracy, we'd start by drawing the plane on the ground in 2-point perspective. Then, using a vertical trace and a trace point above the left vanishing point, we draw the inclined plane. Then, simply drop the verticals down to meet the receding diagonals to find the vertical height from the ground. A variation is to start by constructing a triangular prism that would produce a similar inclined plane. The third way is to eyeball the ground plane. Imagine the prism structure, its vanishing point and trace point. For most purposes, eyeballing will work just fine, especially if you've constructed a few of these the long way. You'll begin to develop a sense of what looks right. So, one way or the other, we have verticals dropping down to the ground. From their bases, draw horizontals out to meet the rays of light. Now for the cast shadow. First, draw a line from the lower left corner of the plane to meet the lower horizontal line. This represents the shadow of the plane's left edge. Next, a diagonal line from this point to the horizontal above it. This represents the shadow of the top edge of the plane. And a final line from this point to the plane's lower right corner. This is the inclined right edge's shadow. Erase the rays and construction lines to reveal the shadow's shape. Erase the portion we wouldn't see, and you can treat the shadow shape with value. Try this a couple more times. Try different types of inclined planes, different directions of plane and directions of light. Like most of the things we've done, getting a grasp of this comes with repetition and variation. When most artists draw from their imaginations, they don't plot all this out with a ruler, though of course some do, but they use the principles and procedures to ballpark things so they'll be convincing. As with many things in drawing, you'll begin to develop a feel for what these kinds of cast shadows should look like if you go through this methodically several times. You'll begin to have an instinctual feel for how the shadows should relate to one another, to the point of view, and to the time of day.